Welcome to the Trend Detection Podcast, powered by Siemens. And now your host, Niall Sullivan.
Hello, and welcome to this episode of the Trend Detection Podcast. I'm really pleased it's quite a special episode today, and we've got one of our customers, Chris from Bluescope Steel, and we've got a really interesting discussion today about a particular success case that recently came through to us, which is really fantastic. We're going to dive into exactly what had happened and how that was resolved with the help of with Senseye as well. But I guess before we get started, I'll just hand over to Chris just to introduce yourself. So over to you, Chris.
Yeah, g'day. My name's Chris. I work for Bluescope Steel out of our Port Kembla site, which is in Australia. I have a background in maintenance. I've always worked in maintenance ever since I left school. I joined Bluescope 17, 18 years ago, and I've worked at the metal K lines for most of that time. Start of 2022, we started a pilot program in my native department, and that was to introduce predictive maintenance. We chose Senseye over 3 or 4 different platforms. And that was mainly around the AI component and the ability to tune it sort of automatically with the thumbs up and thumbs down feature. That was the initial attraction. Things have changed remarkably since then. We've had 3 or 4 massive sort of step changes in the capability of the app. And, we went through the pilot program. It took roughly 12 months. We onboarded around 300 assets across 3 metal coating lines. And once the pilot was complete, we decided to roll out Australia-wide, basically, and that's what I'm responsible for. So I'm predictive maintenance lead for Bluescope Steel, Australian Steel products. We do support our global rollout as well, which is pushing into US, China, Thailand, New Zealand, and a few other bits and pieces around the place. So I have the awesome job of leading that regime, I guess you'd call it. So we've been going since 2022, and we're just about to kick off in the US. We're probably 6 months deep in New Zealand, maybe 18 months deep in Western Port or Melbourne, and across here at Port Kembla, we're pushing into most of our business units. So it's really cool to be part of, and our team's growing, so we're trying to accelerate how quickly we onboard and get things monitored through Senseye. So, and also that's supported by a pretty elaborate LoRaWAN network of sensors to add a little bit of context when we're lacking some of the data we need to onboard our assets. And like our steel mill have the complete array of age of equipment and complexity of equipment, from the very, very simple to the latest and the most modern equipment. So we're dealing with a vast variety of equipment, and everything from bringing in iron ore and raw materials to completely finished products going out the gate to our customers. So it's pretty when I say steel mill, it's the whole thing from front to back. So it's very cool to be part of that. And I spent a long time just in one department. Now I sort of pop up around the place and try to understand what the needs are of that particular business unit, and see where Senseye can most quickly help them out with what they are, what their sort of pain points are. So that's a bit about me and what I do.
Fantastic. No, really good. Really good background there, Chris. And I guess you mentioned, the scaling of the platform across all those different sites globally, which was really fantastic to hear. What would you say has sort of been the key to that, to that global rollout? It doesn't always happen that way.
I guess the success stories always spark people's interest, and that they kind of multiply when people sort of hear some of the success stories we've had, and they're like, oh yeah, I have similar equipment, I have similar needs in my department. Or it's completely the other way, where people are like, oh, that's cool, but can you do something with this? And it's still all about people and engaging them in the right way, and finding every department will have those 2 or 3 people that sort of naturally jump at the chance to do something like this. And it's finding those people and getting started with them, and that first sort of couple of success stories that come from their own department, and that's when the more people like from that particular department, they jump on the hype train, I guess you'd say, and it just multiplies from there. And then we start to talk about our latest sort of thing is to increase the rate of onboarding, where we're trying to find as many people as we can in department to onboard, say, 5 assets a month. So if you start to, if you find 3, 4, 5 people, and then, you expand their capabilities to get them up to 5 a month, and then you add more people to that group, and then you add more to their capabilities, they can onboard more assets, per month. So that's the latest theory on how we're trying to roll out. So it's a big push about training and upskilling our people and giving them access to the platforms, training them up. And the LoRaWAN network is handy, particularly on some of the older, less critical sort of equipment. Like, we do our critical things quite well. We find it's sort of that next layer of criticality, not the ultra important stuff. It's the next layer down that can not, that doesn't get as much love as the critical stuff, where we can really start to make an impact on detecting anomalies and trending sort of metrics that we're interested in. And that's where we can make most of the impact. And that's and that sort of maybe frees you up to do the critical stuff better. And not to say that we can't do anything with the critical stuff. It's just it's critical for a reason, because it's probably a little bit more complex, and it takes a little bit longer to understand how we can implement Senseye sort of in those more complex sort of processes or machines. So that's generally how we try to do things.
Yeah. And is it generally, I guess the general point is it's about building momentum internally. I mean, or getting on people don't want to miss out if something really positive is happening internally. So how important is sort of sharing the successes internally and widely? And how do you do that, I guess, as well?
We have so many different steering committees and focus groups, and we have groups of asset managers that meet regularly, and there's so many different ways. We have local intranets we can push out, but it really is those one pages. I think you'd probably come across. We send a lot of them through to our day-to-day sort of Senseye contacts and Siemens contacts that we report into, and I'm not sure where they end up in your organization, but that's a really good way of sparking interest. And then and those people that, it's always easier to go to people that are interested and they have a few people that have got some spare time and they've got a little bit of spare capacity and money to kick it off. It's really hard to ignore those people, and they might not be the areas that we've been asked to focus on. So there's critical parts of our business that we need to improve reliability or capacity because of expansions or whatever we need to do. But then so we've got to go to the critical people, and then there's sort of the next group of people that sort of haven't been deemed as our critical departments that need the help. It's the other ones that have, maybe a will and a few spare people that you can't ignore them, because they're so enthusiastic and they're so on board and they want to jump on the hype train and get things going in their department. So it's a bit of a balancing act, but we're our small team, and it is a small team. It's growing at the moment, so that's good. And as sort of things maybe toughen up in the steel market, it's one of our key focuses is to roll out predictive maintenance and save money through routine maintenance, and also avoiding those critical breakdowns that cost you time, money, and lost production, all those types of things. So it's definitely central to our business now.
Yeah, so that is interesting. You mentioned about what do we as Siemens do internally. So we do share them internally, because obviously we want to celebrate successes with customers. And I think the people are amazed by some of the, especially with the Bluescope Steel case or project as an example, because some of the figures on there almost to some people is like, wow, is that really true? Kind of thing. That is a common thing with Senseye generally. Is that really true? Can it really do what it says? But do you encounter that kind of sort of skepticism internally when you see these great successes and numbers and what's going on in the project?
Well, we're very cautious about, overestimating, and it is a lot of estimating in when you sort of avoid some sort of breakdown like the one we're sort of talking about today. It is a little bit subjective, but we always are quite conservative when we do estimations, and it's also based on past experience too. Like, this particular one we're talking about, this hydraulic success case where we avoided 24 hours downtime on a metal coating line. We know that is, it's still conservative because of the potential ramifications of this particular failure or potential failure. So we are always very conservative, and we report this into the highest level of our company. So we always have in the back of our mind that we need to back up our estimations with some sort of facts and figures. And generally we don't do that ourselves as a predictive maintenance group. We rely on the local departments to sort of make those estimations, and we're always very, very conservative in that space. So we're sort of always open to scrutiny, and the second that that credibility is gone, then it's gone forever. So we're always very, very conservative in that space when we make estimations, and it's based around sort of potential lost revenue is most of the things that we calculate. But now sort of our general management and executive are pushing us towards well now that we've got this sort of monitoring in place on certain assets, the next step is to start to roll back some of the maintenance, the routine maintenance we have. And you need to have a little bit of longevity in the app and confidence in what you're seeing that the app's telling you to start to do that. That's when you start to get brave and turn off those maintenance plans that have got us to the point where we are now, and it keeps things ticking over. That's when you really know you're cooking, that you've got the confidence of the local maintenance practitioners to start to turn off those maintenance plans and rely on what the app is actually telling you. So that's a big step. It's definitely a big step.
Yeah, it's that element of trusting, getting to the point of where you trust the app and what it's telling you, right? And that's obviously a very key point for adoption or widespread adoption.
It is. It actually is, and it's those. You might save 2 or 3 maintenance people from coming in Saturday night for a Saturday night breakdown, and no one likes doing that, right? Like, no, everyone hates that, and that's one of the things I really want to save people from doing, those Saturday night discos where you get a phone call in the middle of the night, come to work and fix this. So we're trying to make sure that doesn't happen. And when you save people from having to do that a couple of times, they're on board, and but it takes a whole bunch more than that to get a whole department on board, where to the point where they're like, okay, we're going to start rolling back some of our maintenance plans and fully trusting, and we're all in on this sort of process. So that's the battle that we're I think we're winning it in at least most of the places where we're rolling out in. So yeah, it's very encouraging. Very encouraging.
Yeah. And just before we go into that specific case, success case we're going to talk about today, maybe Chris, you explain a little bit more about the KPIs. So you mentioned a few, the KPIs that you maybe report upwards, or that you and the global teams track. Maybe you could go into a bit more detail about that.
So when we first started rolling out, and within the trial period, we would report sort of downtime avoided. Like you'd see a problem with a specific machine, and you'd manage that problem until some predetermined downtime, or you manage it to the next shutdown or whatever. And that would be, okay, we saved 12 hours downtime by managing that blower or that motor or to that maintenance window. We take care of it then and there, and we've avoided a line stop, an unplanned line stop, and some downtime. So that's where we sort of started out. But maybe as your production units become less loaded and there's idle time, then downtime avoided kind of becomes useless. So you sort of change your thinking a little bit into the point where, okay, so we have, maybe detected a problem with a machine, a pump or a blower or a motor, and, we've pulled it out of service and replaced it with a refurbished or a new unit. And, that repair on that motor, because the bearing, we detected it was hot and we managed it to the point where the shutdown was, but it kept running and the bearing didn't collapse, which means we didn't damage the shaft or the housing. So the repair is a lot more efficient or cost efficient than what it would have been if we wouldn't have detected that and we had an in-service failure. So we're trying to, instead of the downtime avoided, we're like, okay, now we're saving money by, repairing equipment in a much less sort of failed state than what it would have been if we didn't have the monitoring in place. So we're trying to measure that, and we're trying to measure what's the gain of offsetting maintenance plans, like either changing the frequency or shutting them down altogether and just making them like a manual call when the app tells us that, okay, this asset's displaying some elevated temperatures or vibrations or current metrics that we haven't seen before, and now's the time to sort of, okay, let's do an inspection at the next maintenance window. So we're trying to calculate offset savings from reducing or shutting down maintenance plans. And there's sort of a general rule of thumb: if you do something in a planned fashion, you're going to get the most efficient labor cost outcome in that space, rather than doing it after hours or in an unplanned type fashion. So there's savings to be had with doing things in a planned fashion. In theory, the less repair bills, and also shutting down of the routine maintenance, and we only execute instead of time based. We're doing it when basically Senseye tells us to. So and if you sort of gear that towards, if you start at the things that are frequent and we're using outside labor, if you sort of start there, they're the sort of big money winners if you start in that space. But also there's thoughts of internal labor is still valuable, and we always have more work on than what we have labor available. So there's still money to be saved, and I guess how we think about it is we're sort of offloading some of those routine inspections or line walks or whatever, and we're making our people, we're freeing people up from that to redeploy them to more critical, higher level things than just doing some, nice to do, nice to feel inspections that 9 times out of 10 don't really tell you anything. So that's the latest sort of metrics that we're looking with.
Yeah, I think that's really interesting, actually, how you say, like you said, it's evolved from looking at things like downtime, because we often say with Senseye, it's actually looking beyond. We encourage people to look beyond downtime as like the metric to measure success. So that so that's really really interesting. But if we look now at the specific case you mentioned before, so the hydraulic system. And maybe, I guess, first of all, Chris, we could just go into a bit of a brief overview of the background to it, where it's located and that kind of thing, and what's happening with it.
But some things get left behind because that's there's a certain amount of engineering time and money and resources to upgrade, and you want to obviously you look at bang for buck type stuff, and you get into this space where a few bits and pieces get left behind, and maybe this hydraulic system that used to just hold a few snubbers in the air, and when the line stopped, it'd lower a few snubbers, and that would be it'd be sort of a low criticality, doesn't really matter if it stops type piece of equipment. And as you sort of upgrade and modernize things, I think there was a big movement to go from like water-based hydraulics, which would service most of our exit ends around our recoilers and coil cars and stuff like that. Anything with a really big cylinder on it, we would use sort of water-based hydraulics on, and anything a little bit smaller, it'd be sort of mineral-based sort of equipment. So, and now we've got our mineral hydraulics servicing some really critical equipment that we use every time we strip a coil off the end of a metal coating line, and all the equipment's now driven by mineral hydraulics instead of the old water-based hydraulics. So, you convert over your valves and you maybe change out a few cylinders and stuff like that. So that's how a typical sort of upgrade would look. But maybe some of the hydraulic system upgrades, there's not a lot of detection or sensors on them, making sure that's all happy and safe and doing what it needs to do. So maybe that's been overlooked or outside scope or no money left or, multitude of reasons to, maybe not touch a hydraulic because it just, it pumps out hydraulic pressure. It does its job until things sort of go wrong, I guess. And you end up with really nice new core cars and hydraulic equipment, and maybe your hydraulic system's not quite up to scratch. So, that's kind of a space we might have fallen into here and there along the way. But so that's how we get into that sort of space, and then you want to start to monitor everything with Senseye, and this hydraulic system's quite integral to what we do. What sensors do we have to monitor it and see how it works? And we have a visual based sight blast that tells us the level, and we have a low level stop everything type switch, and that's all we got. So there's not a lot you can do with that with Senseye. So we need to potentially add in a few little IoT wireless devices, which are, they're not perfect by any stretch of the imagination, but for what you pay and the convenience of just adding a wireless sensor to an older type generation hydraulic system. In this particular one, our Western Port team added a pressure transmitter to just use that to keep an eye on the head level in the tank. So that's what they've done in that particular one, and that does a good job. Some other sensors that we've used in that sort of space too is there's other sort of in-tank arrangements where you could drop a probe in and it'll give you a level and a temperature as well. So that's kind of handy on hydraulic systems. But yeah, this particular example that's what they've done in Western Port. So they've just added an IoT pressure sensor to keep an eye on the tank level, and it's doing you get maybe a data packet every half an hour, which is fine for and you probably cover off a fair amount of your failure modes with just big volume leaks are always going to be problematic because you don't have very long to remedy what's going on before it's game over. But the slower, sort of less noticeable leak is sort of the failure mode we're looking at trying to cover off here. And this sensor was maybe installed 6 months before the actual detection occurred, and it's sort of just sitting there reporting on the tank level. And all of a sudden we had a case come up, and it was and Chris had turned on forecasting, which is another feature of the Senseye app. It sort of, you set up a threshold and go, okay, this tank, when it gets down to sort of a level of 60, I'd like to know about it. And so you set your threshold up, and then we turn on the threshold, so it sort of predicts in the future, like based on the current metrics of how that level is tracking, maybe in a couple of weeks that you're going to be at that tank low level that you wanted to be reminded of when that was due to happen. So they got a threshold detection from Senseye. They went and did a bit of investigation. So this tank is it's under the normal operating floor, so no one normally goes into that particular area to keep an eye on it. And of course, it services the whole exit end of this particular metal coating line. So there's pipe work running off in all different ways, going to all different sorts of equipment in the exit end. But they use that detection to go, okay, we need to go and investigate. We've got a trend that tells us that we're losing tank level, and we need to go and take a look around and try and figure out, do we have a leak? Where is the leak? Is the leak visible? Let's go and just do an inspection on the tank. So quick look around the tank, couldn't find anything. So they start to follow a bit of pipe work. They ended up in a coal car pit. where there's some fixed pipe work that runs to fuel the mobile core cars. And yeah, I mean, I don't know if you've seen the picture, but you can see there's some fixed pipe work there. From the picture, it looks like it might be like 3/4 of an inch or half an inch pipe work, and you see on one of the joins there that it's just sprung a leak, and that leak was in an area of the plant where, you know, it's down under the normal operating floor. People don't go down there unless they generally have a very good reason to go down there, because it's, you know, it's dark, it's slippery, it's not a place that people are meant to go and take a look at those things. So they found the leak, which was really good. They thought that, you know, okay, the night shift crew found the leak. They thought that it would be okay. They just topped up the tank to cover off that. But, you know, you can't run like that, because there's always potential, because a leak like that can get quite bad quite quickly. So I guess the way that the offset or the downtime avoided was saved is they had time to secure the hydraulic system and also secure the production line. So when metal coating lines, if you don't progress the strip through the metal bath, you can burn the strip off, and that's, you know, then you need to rethread your metal coating line. That's kind of where the 24-hour downtime avoided comes from. So it gave the operations team time to secure the production line, to set up it, to get the line set up so they could actually take some downtime and work on this hydraulic system and make repairs to the hydraulic pipe work. So we don't have Boilermakers on shift, so we had to wait for the day shift crew to come in, and, you know, by that time the line was set up, and, you know, we could get a Boilermaker in there to make some repairs. I think they ended up repairing it in situ, just tried to weld up the hole in the pipe, and till they could get it to a proper, you know, maintenance outage where they could pull the pipe work out and either get it replaced or repaired in a workshop. So that's the general story of that one, of that particular success case.
Yeah, no, I think it was really interesting going into that sort of detail about it, really understanding. Is, you know, it's rare that, unfortunately, I'd love to speak to customers more about these and understand exactly what goes beyond what I see on that slide that shared internally. I guess it's all, like you said, it's also like a health and safety issue as well, right? Because you said people shouldn't really go down there unless there's a really good reason. So it's actually, rather than, again, if people can go down there when they know they need to, then that's obviously a benefit, right?
Yeah, and that's not sort of the only safety concern that's sort of wrapped up in this episode. So yeah, you know, we had the hydraulic leak. That's not good. There's always potential hazards involved in that, and, you know, working in and around that. So this hydraulic system, if we didn't have any sort of forewarning, the only protection we had outside of the IoT and Senseye is that low level switch. If that activates, it stops the pump dead, and you can't restart it until you you get some level, recover some level back into the tank, because that's set up to protect the pumps, right? That's pretty standard. That would render our exit end of that production line, you couldn't move it. It would be, you couldn't move it forward or backwards. There'd be no permissives or any of the hydraulic systems to make the exit end move. So yeah, you would not be able to progress the strip through the metal bath, and then you burn it off. The problem, like one of the bigger problems with that, is that then exposes a lot of our operation teams to do a lot of manual handling of the strip to recover it, and that's not great. You know, like, you know, we have precautions on how we deal with that, but it's always better not to do it at all. So you know, there's always lots of potentials for strains and sprains and you know, cuts and abrasions when you're handling, you know, sort of light gauge metal strip. So that is definitely another thing to consider, and that doesn't come across in the success slide, but, you know, that's when you talk about them internally, that's another thing that, you know, someone normally talks about is there's always sort of multiplying factors when you sort of avoid situations like this. Yeah. No, absolutely. It's not, because I guess the focus is usually, you know, you see the big headline figure. I mean, in this case, I think it was 24 hours downtime, you know, saved, I believe, on this one. But yeah, it's all these other benefits or outcomes as well, which are, you know,
just as important, you could say. I suppose, well, more important if you think about health and safety.
Definitely.
I was going to touch on, because you mentioned about the forecasting functionality in Senseye. I wanted to combine that with obviously the new piece of functionality, relatively new, and going to be enhanced even further very shortly as well. But the copilot functionality. So I guess first of all, Chris, maybe just your general view on the functionality, so far, and you and your colleagues, what their experience of it. But in this particular example, how did it? Because I know it was featured on the success side. How has it helped to identify the fault? And
Well, it just helps build confidence in what it can do, and it gets people very excited about, because it's still very I guess I'd call it juvenile. Like, it's not very far down the track, and that's based on us and our case feedback, and how much better the AI will be once it ingests all that sort of information, and it sees next time we see a case like this, that's one of the likely causes it's obviously going to throw at us. And it didn't even need to see sort of that, like, because I had a look at what the copilot said about this particular case, and it mentioned three things. And like, if you think about, what would you think about if you were seeing a decline in the hydraulic tank level? Like, you'd go, okay, we've got a leak. That's pretty basic. Yep, nailed that one. And then it spoke about, this might be a natural consumption of oil, and that's also a possibility. We do have other sort of lubrication, not so much hydraulic tanks, but other lubrication systems where, as we change out work rolls here and there's an amount of lubricating oil in the work roll bearing that you lose when you pull that roll out of service. So that's a likely thing in our space. And the other one is, well, whatever you've got to measure the level is faulty. So if you had a bit of a think about what would be the three off the top of your head, the top three likely scenarios that probably you could generate from seeing a decline in the tank level like this, they'd probably the top three that I'd think of. And the AI component, like the copilot, has picked that up. I mean, this is not an overly complex type of case, but yeah, it's sort of just, it gives people a little bit of confidence. Like, okay, this is worth, when you do get a case, it's like, it is worth taking a look at that particular suggestions or likely outcomes that the copilot throws up at you. So that's really good. And it gets people excited, like, what's going to happen to the copilot when we start, we have multiple cases, and, how is that going to affect it and enrich the feedback that we're going to get from it? If we put good, solid case feedback in, how much more is that going to enrich the AI's capability of, collecting the information and storing that sort of knowledge within the system that we have from now for the next generation to use and to build on. So that's a really important part of what the app can do. Like, we do have, let's say, a very experienced workforce, and some of them coming to the end of their careers, and how do we get what they know into a platform like this? And case feedback is a very good way, and also the possibility of uploading documentation and having the AI ingest that is also, that gets people really excited, because there's a multitude of documents that we have that we can upload into the system to help us out with the copilot and what it can, the power of that and what it can do. Because like in a couple of years' time, this one might not be super complicated for everyone to look at, but there's other ones that aren't. Maybe when the data that we have available isn't straightforward in explaining what's actually happening with the system. So the potential is huge, and we're quite excited about where we can take this. And yeah, can't wait till we can upload documents and have that uploaded into the AI, and yeah, excited about that.
Yeah, And that should, I was about to put a timeline on it, but I'm sure you're in very close contact, I know, with Dan and the team, so they'll keep you updated with that. But I know that is something being actively,
Yeah.
explored and worked on. That's one thing I can say. And you're right, it's very. So I guess what you're saying, Chris, as well, it's almost this single source of truth that for information and knowledge capture, and that's what we've sort of identified with this as well. It's not just like a gimmicky kind of thing, but it's actually somewhere you can capture knowledge. And then we term it, and talking to other customers as well, I can sort of see where this works. It's almost like a virtual maintenance person who knows everything about your every asset, or in theory, has the data, of course, to start with, and the knowledge.
Yeah, absolutely. And like, I think it was because we've been playing with we were involved in the beta trial of this, and I think it was maybe day 3. We had a case where we're just monitoring the relationship between like a process variable and a control valve. And, it had been synchronized for so long, I'm at 100% flow, like 100% valve open, and I'm getting a flow of X. And then like that relationship was well established, and it had been in the app for a while. But then we started seeing a drift. We started to have to use more valve position to maintain that same sort of flow. And what the copilot came up with, it was kind of a little bit mind-boggling. And like, where does it get this information from? How does it do it? Like, and maybe not everyone that comes across it understands how it works. I certainly don't. But it was saying something like, you've potentially got a restriction in your pipe, or you've got a problem with your control valve, like the calibration of your control valve's out, or what you're using to measure your process variable has drifted. And I'm like, that's kind of, if you sat down and thought about it, you'd probably go, yeah, okay, they're probably 3 really good scenarios. And I'm like, this thing's 3 days old. Like, this is kind of ridiculous what it can do. And that was a little bit scary in terms of, well, where can we take this? Like, what's it going to be like in a couple of years' time when it's had time to ingest more and see more data? And it's I think that's a really strong point of this particular platform. And it makes it, like you show them just the standard stuff. Oh yeah, we just monitor tank level, and you show your customers that, and they're like, oh, that's cool, that'd be kind of handy. But then you show them some of the more higher level, complicated machines, and some of the cases in the copilot feedback. It's like, this has a lot of potential. And you say, oh, by the way, we can feed this thing any sort of functional specifications we have, or anything, maintenance procedures, feed it anything. And how does it take the wording in your functional specs and relate it to the wording that you called like your measures? I don't know, but that's going to be the fun part, figuring that out, and how that all is going to benefit, I guess, everyone that comes across the app. So very exciting. The potential is kind of mind-boggling, and yeah, can't wait to. I think we'll have our hands on it by the end of the year.
Yeah,
absolutely.
Absolutely. And I think for you guys as well, it's almost a very big opportunity. You've got with the global rollout you're talking about. You talk about knowledge sharing and stuff. Be able to compare this case over here to this case over here. Maybe even have discussions and ask questions, bring people into the conversation. I mean, I am getting ahead of myself because that might be a bit later on, so I'm not promising this. But I think this is where it's heading. I can safely say it's probably where it's heading at some point in the future. To bring, the collaboration between machine, people, and the copilot basically is sort of where I think it's going.
And we don't have a lot of. I can't think of another platform that we have that is like a global platform that anyone in our business can take a look at. Like, we have lots of metal coating lines around the world, and like, they don't actually have to talk to me about, well, where have you deployed monitoring, like what machines and how have you done it. They can just jump onto the app and take a look, which is that's really good. And you're talking about comparing assets to assets, and they don't have to be sitting beside each other. They can be on the other side of the world. Like we have lots of inductors we use to heat up, metal. There's no reason why we can't have like a global dashboard with all the same measures on there, comparing inductors in Thailand to Port Kembla to Melbourne to New Zealand. It's a good platform. There's not a lot of other platforms we have where we can see real time data on all those different sort of assets from different parts of the world. And if you've got a problem with your particular inductor and I've noticed that this conductance ratio or something like that, or this power factor's changed from here to here, can I find that in, did this happen somewhere else? I might be in Port Kembla. Have I seen this anywhere else around the business? And there's an inductor in New Zealand that did the same thing 6 months ago, but it's still chugging along. It's still okay. Like it's still hanging in there. And now I feel a little bit more okay. I feel a little bit more comfortable with what I'm seeing. Like you can. I don't know what this is going to like. It's great to have data. It's one thing to have data. It's another thing to know how to react to it. And I guess that's where co-piloting can help. But just being able to find that particular data in another asset on the other side of the world without even talking to them is, that's a phenomenal advantage to have as well. So that's good.
Yeah, no, very powerful stuff. Very powerful stuff. I'm conscious of our time because we're slightly over, and I know it's late where you are, early where I am, but not that matters. But it's late where you are, most importantly. So I don't want to keep you too much on. But I just thought to finish, it'd be interesting. And thank you for sharing. You're so much on that particular case and your experience in Senseye. It's really useful for the audience. But just to finish, I guess for other companies now looking at deploying predictive maintenance solutions, is there any sort of particular advice you would give, Chris, as you're, I'd say in the middle of a successful deployment, because it's still ongoing, like I said, with new sites coming on all the time. But do you have any advice for people what they need to sort of think about and consider?
I think find a good vendor is a good thing. Find a good vendor. And we do a lot of digital transformation stuff on different platforms. We have like connected field workers and authority to work systems, and another maintenance platform that we're in the middle of, and they're up to different stages of MVP type stuff and just about to roll out type thing. Find a good vendor that's going to be willing to work with you. That's a good piece of the puzzle. It's still all about people. Digital transformation is definitely all about people. Finding the right people within your business that are, maybe sick of banging their head against a brick wall and getting the same result to, what can we do to get better? Like, what's going to be the next step change in our performance? If you find people that are thirsty for that, find those people and put them in the thick of things. And the last one is, data. Got to have data. Data's kind of good. And, there's ways of supplementing what you have. Like we do reasonably good things. Like this is like tank level is one, and that's not a complex piece of data. That's a very simple piece of data, and it's sometimes what you do with it rather than what it actually is. And we have other things like where we just monitor how many times a hydraulic pump starts to lift a dead weight accumulator into the air per shift, and normal's 2 or 3 times it starts in a 12-hour shift. What does it mean if it starts 6? It probably means we've got a leak for somewhere. And another group that, not this particular group in Western Port, but the plate mill people up here in Port Kembla, like they know that if that pump starts 6 or 7 times in a shift compared to the normal 2 or 3, they know they've got a leak somewhere. And they know that hydraulic system, it supplies that cylinder, and then that particular valve bank, and they just go for a walk around. And 9 times out of 10, they can see a fairly obvious leak somewhere. So it's also get your hands on your data, and it doesn't have to be anything super complex to get started. And once you get started, you'll innovate and tap into other people that we should get a global sort of Senseye customers forum going that we can just share a few ideas and I'm sure there'd be some benefit in that. That would be my take. And it takes a lot of energy, but that's all right. You got to find those people with the energy and the passion and the drive to do it, and the success will just come. Trust the process; it'll come.
Yeah, absolutely. No, really good advice there. And I mean, I guess we call them sort of champions as well. So people really, sort of passionate, believe in it, and can really drive it within organisation as well, or across organisation, I guess, is key, like you said. But no, thank you. Yeah, thank you so much for your time again, Chris. I found it really interesting diving into that success case, but also obviously learning more about the overall sort of Bluescope project, and long may it continue as well. So to that, but I guess if people want to sort of reach out to you directly, maybe on LinkedIn or something like that, possibly.
Not actually on LinkedIn yet. I need to get round to do that. That might be a good opportunity for me, but I guess if they're your customers, then they can reach out. They can probably get to me through the Siemens people.
Exactly. That's a very good point. I don't know. I presume everyone's on LinkedIn, but just because I am doesn't mean everyone else is. But no, that's absolutely true. So please reach out to the Siemens team, and we can either make an introduction to Chris, or just explain a little bit more about the fantastic success going on there as well. But for now, thank you, Chris, for your time and for taking part, and thank you everyone out there for listening. And we'll see you on the next episode. Thank you very much.
Thanks.
Please like and subscribe on all major podcast channels, and find out more about Senseye Predictive Maintenance at Siemens.com.